Hello everyone, welcome back to our channel and I hope you are doing good. So today we are going to see the mathematical analysis theorems first unit. The first theorem we are going to learn today is every neighborhood is an open set. Whenever you are writing the proofs of these theorems, first you need to write what is the given part. Here the given part is every neighborhood is an open set. We need to prove. So write the definition of what is a neighborhood and what is an open set. And try to understand what is the statement. If you have understood the definitions correctly, then you can easily prove the theorems. Okay? And if you have not watched my previous videos of these definitions, I request you to go to the description box and check the links there and go through it. Then only you can understand this theorem proof. And we know that neighborhood is denoted as NR of P. So I am considering E has this one. Let E be neighborhood of a point P. Then we need to prove this E is an open set. What is meant by open set? If every point of E is interior point of E, then it is called as open set. In order to prove what is an interior point, the interior point is the neighborhood of a point P is subset to E. Here just simply, here the taken the neighborhood of point P. In place of point P, I am considering point Q and I am taking the radius as epsilon, which is nothing but n epsilon Q is subset to E. I am considering E has NR of P. So subset to NR of P. This is what we need to prove. I hope it's clear what is statement and what we need to prove. In order to prove this, first I need to consider that this Q be any point in E. Right? So now let us go into the proof. First, let E be neighborhood of point P. Neighborhood of point P and E is equals to NR of P, which is denoted as distance between P comma Q is less than R and R is greater than 0. The R is radius of a neighborhood point. In order to prove this one, first we need to consider Q be any point in set E. So let Q be any point in E. ఇది మనం ప్రూవ్ చేయాలంటే Q అనేది ఈలో ఏదైనా ఒక పాయింట్ అని అనుకోవాలి. ఎందుకంటే మనం ఇక్కడ ఏం ప్రూవ్ చేస్తున్నాం? ఇంటీరియర్ పాయింట్. ఇంటీరియర్ పాయింట్ అంటే నైబర్హుడ్ ఆఫ్ ఎ పాయింట్ P ఈజ్ సబ్సెట్ టు E. And open set is nothing but every point of E is an interior point of E. So try to understand the definitions so that you can easily understand this proof. Let Q be any point in E అన్నప్పుడు Q belongs to E. Q అనేది E యొక్క Eలో ఏదైనా ఒక పాయింట్ అనుకుంటే this Q belongs to E. E అనేది ఏంటి? NR of P. Right? And distance between P comma Q is less than R. Now let us consider epsilon. This epsilon, this E is different from this E. This E is set E and this E is epsilon, the small integer value, which is equals to R minus distance between Q comma P. And consider it has equation 1. And we know that what is d of Q comma P, which is nothing but the distance between Q and P. This is the distance between Q and P, and here R is the radius of neighborhood point. This is radius of neighborhood point. Neighborhood point. And now let us consider the neighborhood of point Q. Neighborhood of point Q. Because we considered a point Q in E. Q అనేది ఈలో ఒక పాయింట్ అనుకున్నాం. సో దాని యొక్క నైబర్హుడ్ ఏమవుతుంది? విచ్ ఇస్ నథింగ్ బట్ ఎన్ ఎప్సిలాన్ క్యూ. ఇక్కడ ఒక క్యూ అనేది ఈలో ఒక పాయింట్. సో ఇక్కడ రేడియస్ అనేది ఎప్సిలాన్ తీసుకుంటున్నాను. సో దాని యొక్క నైబర్హుడ్ పాయింట్ ఏమవుతుంది? ఎన్ ఎప్సిలాన్ ఈ అవుతుంది. రైట్. అండ్ మనకి ఇక్కడ ప్రూవ్ చేయాల్సింది ఎన్ ఎప్సిలాన్ క్యూ ఈస్ సబ్సెట్ టు ఎన్ఆర్ పి కదా. సో ఈ క్యూ అనేది ఇంటీరియర్ పాయింట్ అని చూపించాలంటే మనం ఏం ప్రూవ్ చేయాలి? దట్ ద నైబర్హుడ్ ఆఫ్ పాయింట్ క్యూ ఈ సబ్సెట్ టు ఈ అని ప్రూవ్ చేయాలి కదా మరి మనం. Right? This is what we need to prove in order to prove that this Q is an open set. Okay? For this, I am considering let y belongs to n epsilon Q. So, y అనేది ఒక పాయింట్ తీసుకుంటే this y belongs to n epsilon Q అనుకుంటున్నాను. సో దీన్ని ఎలా రాయొచ్చు? The distance between Q comma y is less than epsilon. మనం nr of pని ఎలా అనుకుంటాం? What is the neighborhood of a point P definition? Which is nothing but let x comma d be a metric space and the neighborhood point P consisting set of points Q such that distance between p comma q is less than r అన్నప్పుడు ఇక్కడ n epsilon q అంటే x comma d be a metric space and the neighborhood of q consisting y points such that distance between q comma y is less than epsilon. I can write like this, right? So I have written in this way. And we know that in a metric space we have 4 properties. If you remember, the fourth property is triangular inequality property. Triangular inequality property, the fourth property. From this, I can write the triangular inequality property is d of x comma y is less than or equals to d of x comma r plus d of r comma y. I can write distance between y comma p is less than or equals to distance between y comma q plus distance between q comma p. Right? I can write like this. And we know that distance between y comma q or distance between q comma y, which is same, x comma y or y comma x, which is according to the symmetric property, which is less than epsilon. So I can write less than epsilon plus, in the above equation first we considered epsilon is equals to r minus distance between q comma p, right? So if we send this d q comma p this side, then we get distance between q comma p is equals to r minus epsilon. So I can substitute this here, which is r minus epsilon, right? So we get distance of y comma p is less than r. Epsilon cancel, which is less than r. I can write this as nr of p y belongs to NR of P. I can write like this, right? Because distance of Q comma P comma Q can be written as NR of P, right? So from this equation, if you see, y belongs to n epsilon q. This can be written as distance between q comma y is less than epsilon. So if you compare this equation and this equation, so I can write like this: y belongs to NR of P. So I hope it's clear. From above, we got y belongs to NR of P. And we also know y belongs to n epsilon q. We have this both, right? So from this, here the epsilon is r minus d of q comma p, which is nothing but this epsilon is small value than this radius r. So from this both equation and this one, I can write n epsilon q is subset to NR of P has y belongs to NR of P and y belongs to n epsilon q, and epsilon is equals to r minus d q comma p, which is nothing but this equation is stating that this q is an interior point of NR of P. What is the interior point? Main thing. The interior point main thing is we need to show that the neighborhood of any point should be subset to E, right? Here, instead of P, we have the point Q, and instead of radius R, we have epsilon subset to E, which is nothing but E is NR of P only, as we considered in the above, right? And open set, we need to prove that open set, right? Every neighborhood is an open set. What is an open set definition? Every point of E is an interior point of E. We already proved Q is an interior point. So which is nothing but every point of E, and in the above only we consider Q is any point in E. So this Q is any point in E if every point of Q is subset to E. This is E, right? And every point of E is an interior point of E. Then we can say that this is an open set. So therefore Q is an interior point of NR of P, and which is nothing but NR of P is E. Therefore we can say that this NR of P is open set. Hence we proved, right? This is what we need to prove, and we got it. I hope you have understood, and if you have any confusion, you can also rewatch it and you will get a clarity. Thank you all. Happy learning.